Hello! My name is Luis.
My name is Mau.
My name is Charlie. And today we are going to talk about the oil spill.
In today's episode, we are going to understand what happened in Cadereyta Jimenez.
We are going to analyze in a different way and more specific what are the consequences of petroleum in water.
Okay, so in here, these ones are the compounds made from carbon and hydrogen.
And as we know, water, which is made with hydrogen and oxygen.
Yes. In these two, we have petroleum and water, and both of them are different types of substances.
The next compound that we are going to analyze is methane. The formula of methane is CH4, and here you can see the Lewis structure of it. As you can see, it has 4 electron pairs, and none of them is a lone pair, so it is a tetrahedral geometry.
The electronegativity of carbon is 2.5 and the one of hydrogen is 2.1. Since the difference between them is less than 0.4, they are covalent non-polar. This means that they do not have dipole-dipole forces and neither hydrogen bond forces. So the only force that they experiment is dispersion forces.
Now we're going to analyze ethene. Ethene is also a hydrocarbon, but this is C2H4, 2 atoms of carbon and 4 of hydrogen. And here we have the Lewis structure. It is made by 1 double bond and 4 bonds, making 3 bonds for each carbon with non-loose pair of electrons. So it's a trigonal planar geometry. Also, it is a non-polar molecule because each hydrogen is well distributed, having 2 on the left and 2 on the right.
The next one is hexane. Hexane is composed by 6 atoms of carbon, 14 atoms of hydrogen, and this one is a Lewis structure. The geometry is tetrahedral, and it's non-polar.
The compound that we are going to analyze is benzene. The formula of benzene is C6H6, and here is the Lewis structure for it. As we can see, each carbon has 3 electron bonds, which one of them is a double electron bond. It is bonded to 2 carbons and 1 hydrogen. Since it has only 3 electron bonds, it has a trigonal planar molecular geometry, and of course it is a non-polar molecule since the attraction between carbon and hydrogen is very low. Since it is a non-polar molecule, it doesn't experience dipole-dipole forces, neither hydrogen bond forces. So the only forces that affect this molecule are dispersion forces.
The next molecule is octane. Octane is made out of 8 atoms of carbon and 8 atoms of hydrogen, 18 atoms of hydrogen. It is a non-polar molecule and it has a tetrahedral geometry. It is non-polar because all of the hydrogens cancel out, and it experiences dispersion forces because it is a non-polar molecule.
Okay, next one is water. Water is made from H2O. This one is the Lewis structure from water. Water suffers these forces, dispersion forces, dipole-dipole, hydrogen bond. And we can see that in the Lewis structure there are 2 lone pairs, so it's a bend, a tetrahedral bend. The electronegativity is, the difference is 1.4, so it's apolar.
Now we have here all our compounds. We have water, that is a covalent polar molecule, and also we have methane, ethane, hexane, benzene, and octane, covalent as well, but non-polar.
Knowing this, we can know the interactions that surge between them. The first is a hydrocarbon with a hydrocarbon, and when this happens, the hydrocarbons dissolve into each other because all of them are nonpolar molecules. The next interaction is water with hydrocarbons, and the interaction between them is that they do not dissolve in each other because the water is polar and the hydrocarbons are nonpolar. And finally, the interaction between water and water is that they dissolve into each other. Finally, we are going to analyze what happens after a real oil spill. First, when the oil touches the water, the oil doesn't dissolve in water because, as we saw, the compounds of oil are non-polar and the water is polar, so they do not dissolve in each other. Then the oil remains on the surface and it creates a thin layer called a sheen.
After this thin layer is created, it can affect many things that live under the water. This thin layer can stay there for many years, and sometimes it is possible to remove it. But even if we remove it, it can still be some remainings of it.
So that's why we need to take action. We need to remove the oil when the oil spills, because it can intoxicate the animals and can kill all the plants.
We hope that all this knowledge helps you to understand more the dangerousness that an oil spill can cause, and also understand the chemical reasons for why this happens.
This is not very dangerous for the animals and very bad for the water. It is also very bad for us that we consume the animals from the water and we drink the water.
See you in the next episode. Thank you for watching.
Bye.
Subscribe.
Bye.
Bye.